At the large scale, the southeast United States currently lies between a departing long-wave trough farther west and an upper ridge building into the eastern states. That places us in a transitional phase, moisture return into the southern tier and coastal zones, while much of the inland southeast has begun to dry under the influence of residual continental high pressure and ridging. The geography matters. Florida's peninsula is bounded by warm Gulf waters to the west and the Atlantic to the east, allowing rapid moisture advection when onshore flow develops. Georgia's terrain slopes from the coastal plain up into the Piedmont and Blue Ridge, which means boundary layers, flow regimes, and moisture responses differ noticeably from west to east across the state. Climatologically, October is a month of transition. Daytime heating begins to wane. Cooler air masses attempt to infiltrate from the north. Yet the oceanic and Gulf surfaces remain warm, so the Florida peninsula retains a propensity for tropical moisture advection, coastal and sea breeze interaction, and localized convection. Georgia, meanwhile, is shifting toward more autumnal conditions with lower dew points, generally drier air, and an increasing chance of high elevation radiational cooling overnight. Mechanisms driving today's activity: moisture advection and boundary layer recovery. In South Florida, the transition from a dry continental air mass to a deeply moist tropical air mass is critical. The veering winds, rising dew points, and high PWAT set the stage for shower/thunder potential, boundary forcing, and frontogenesis. In Georgia, the frontal passage provides lift and convergence, which triggered the morning line of showers, thunderstorms. After the front, ascending motion wanes, and the air mass becomes capped and dry, suppressing further convection. Subsidence inversion and ridging aloft. Where ridging builds, especially inland Georgia, subsidence strengthens the inversion, dries the midlevels, and hampers vertical motion. This promotes the dry and cool regime. Marine and coastal influences. In Florida, onshore flow supplies moisture and creates enhanced tide/wave/flood potential. Sea-and lake breezes generate localized convergence zones in the afternoon, which can spark showers even when large-scale forcing is weak. Diurnal and terrain processes. Overnight fog forms in South Florida due to moist low levels, clearing skies, light winds, and the development of a shallow inversion. In Georgia, overnight radiational cooling under dry air mass will push lows lower. Operational implications for pilots. South Florida. Early morning flight ops should monitor for patchy dense fog inland. Low visibilities may affect ground handling and departures. Throughout the day, coastal and nearshore marine operations need to account for high rip current risk and minor tidal flooding. Convection this afternoon may result in lightning, gusts, and reduced ceilings or visibilities near storms. For en route flights, moisture advection and low-level wind shifts may affect in-flight turbulence and gusting around storms. Florida Peninsula, general. Expect afternoon sea breeze trigger showers, storms, localized but can be intense. Watch for gusty winds during convective downdrafts, particularly near coastal airports or flights crossing peninsula. Georgia. Post-frontal regime means improving skies, drying air mass, and lower humidity, favourable for VFR and general aviation. Gusts may linger behind the front. Fire weather concerns emerging midweek. For early morning departures, cooler temps and lower dew points mean consideration for density altitude or frost in certain terrain later in week. General trends. The shift toward drier, cooler air in the inland southeast may limit turbulence associated with convection, but expect stable nocturnal layers and possible radiation fog or low stratus, especially in valleys. In the coastal southeast, remain alert to marine influences, tide-linked flooding potential, and gusty onshore flows.